All right, we are starting geometry now. Before I start, I'll just tell you that it is the most scoring chapter in your syllabus. Okay, geometry questions will be involving finding out the angles. Mostly the question will be about find the angle A, find the angle B, like this. Also, marks will be awarded for your numerical value as well as for the reason. Okay, your answer will be some value, some number, and half of the marking will be done for the reason. You also have to give the reason in brackets, what property of the geometry you are using to get that particular value. You have to tell them that yeah, I'm using corresponding angle property, I'm using angle sum property, I'm using alternate interior angle property. So as long as you are writing these four things, value and the reason, you will be awarded full marks. If you're only writing the value, then you will only earn half of the marks. Okay, so reason is as important as the final answer. You have to write the reason also. Okay, so the very first part of this chapter start with angle at a point. And on a line. It will be better if you are having your notebook and pen and making notes. Angle at a point and on a line. What does it mean? So everything in this chapter is built from four facts. If you cannot state these instantly, nothing later in the chapter will work. Okay. So what are these four factors? The four foundational factors of this chapter are angles at a point add up to 360 degree. Angles at a point add up to 360 degree. A point is like this, and the sum of all the angles across this point is 360 degree. I'll show you also. This first thing, for example, if you are having this, that's your point. And now from that point I'm drawing a line which is intersected by this line, which is intersected by this line also. So how many angles you are seeing, how many corners you are seeing, that makes the angle. Corners give origin to the angles. So you are seeing these many corners. I'm calling this as angle A, this is angle B, this is angle C, this is angle D, and that point is O point, for example. So the sum of angles at this O point will always add up to 360 degree. That means angle A plus angle B plus angle C plus angle D, they will always make up 360 degree. The sum of all angles, because A, B, C and D are the all angles that we are seeing in this figure. I can make different angles also. See, now I'm gonna say this one here is D and this one is E. So now we'll add E also here. Sum of all angles, okay, they will always add up to 360 degree for a point. That's one thing. Second thing is angles on a straight line always add up to 180 degree. Okay, before moving further, I'll tell you this is the sign of angle. Okay, in maths we can't always write the spelling angle. It's better to show a symbol of angle. This is my symbol of angle, like this, a tilted line and then a horizontal line like this. You can think of the nose of Sonu. So that's how we represent angle in maths. Always in physics also you will use that thing. Okay, second thing, the second foundational point was that angles on a straight line always add up to 180 degree. Angles on a straight line add to 180 degree always. I'll show you how. So this is my line, a straight line. Okay, so you will only see two angles on this straight line. This is my angle A and this is angle B. They are made on a straight line. What straight line? The black line is the straight line. Okay, so angle A plus angle B always add up to 180 degree, always. This figure can be more complicated. I'll show you. Like this, a straight line is this. It can have multiple angles also, like this and this. Now I can say, what angles do you see in this figure? A, B and C. And hence all these three angles are making up to the straight line. This is why the sum of all these three angles will always be 180 degree. That means sum of all angles around a point is 360. Sum of all angles on a straight line is 180. Two things. Now the third foundational thing of the geometry chapter. Vertically opposite angles are equal. Okay, they are the properties, the reasoning that I am asking you to write. If you are writing the answer alone, it will not mark you the full thing. If you want to earn the full marks, you have to write the reasoning, and reasoning comes out of these four foundational things. The first was sum of all angles around a point is 360. Sum of all angles on a straight line is 180. Sum of all angles, okay, no more sum of all angles. The third foundational thing is vertically opposite angles are equal. That's a property. Vertically opposite angles are equal. Now what does it mean? Vertically opposite, the angles which are vertically opposite. So you are seeing this thing here, and this angle and then that particular angle, angle A and angle B, they are vertically opposite, aren't they? They are vertically opposite. They are vertical also, and they are opposite to each other. They are opposite to each other, and hence they will always be equal. Angle A, angle B will always be equal. If you ever see a figure, if you ever see two lines making a X, if you ever see two lines cutting each other, then the angles on the opposite sides will always be equal, and hence angle C will also be equal to angle D. That's a property. The property is known as vertically opposite angles are equal. If you ever see this particular line, two lines cutting each other, then the opposite angles will always be equal. Angle 1 and angle 4. So angle 1 equals angle 2 and angle 3 equals angle 4. That's a property. Okay. Vertically opposite angles are equal. And the fourth foundational thing says angles in a right angle add to 90 degree. That's it. So you already know, in a right angle, when a line is perpendicular on other line, this is my line, and another line is perpendicular to each other. Perpendicular itself means the blue line is making a 90 degree angle. When I say a line is perpendicular, that means it is making 90 degree angle, perpendicular angle. This is how we show. See, all the angles are shown like this with a curve sign, with this curve, but perpendicular angle only will be shown like this. Okay, with this particular thing. This is perpendicular. It means this angle which is made here is 90 degree. This angle is 90 degree and the lines are perpendicular. The angle is right angle. Okay. So how will you solve the questions in geometry? If three angles, for example, I'm showing you an example this time. The question can be asked as three angles meet at a point. There's a point and three angles are being met. What are these three angles? 5x, 3x plus 20 and 140 degree. The question is find the value of x. What is given to us? That we were told in the question that three angles were made around a point. So that is the first foundational property, that the sum of all angles made around the point is 360. That means if you will add all these angles, 5x plus 3x plus 20 plus 140, sum of all these three angles, this one and this one, will always give you what? 360. And you can find the value of x. So 8x plus 140 equals 360. And now 8x equals 360 minus 130, which gives you what? 220. 220. And then 8 equals, then x equals 220 over 8, which finally gives me the value of x. The value of x is 55 over 2. 55 over 2 or 27.5. This is the value of x. Is that your answer? Will you be awarded full marks for that? No. That's just the answer. You have to give the reasoning also. So when you will write this particular thing, 5x plus 3x plus 20 plus 140 equals 360, you have to write what law you are using, what property you are using. So you will write sum of angles. You will write, we already know that. You will say, we know that sum of all angles made around a point, is 360. If you are writing this particular thing and then starting doing the question, then you will be awarded full marks for that. If you're only writing the value, then it earns you no mark. Okay? You have to give the reasoning also. This was the first part of this chapter. Okay? And mostly you will see 60% of the question will be done if you only understand these four properties. The first property was angles made around a point always sum to 360. Angles on a straight line always sum to 180. Vertically opposite angles are equal. Vertically opposite angles are equal, like this. And then perpendicular lines make right angle. Perpendicular lines makes angle equal to 90. That's all. Now comes the parallel lines. Okay, there are multiple properties we need to understand for the parallel lines for solving the questions in geometry. Okay, now I'm starting the part 2 of this chapter. Part 2 is the study of parallel lines, specifically about the parallel lines. We already know what are parallel lines. Parallel lines are those lines which never intersect, which never cut. They will never cut. If you infinitely raise them on either sides, they will never meet. Okay. See, this is one line and this is one line. You can ask me, sir, these two lines will also never meet. They will go like this. They will never meet. There's no chance that at the infinite distance also they will meet. But I'm gonna ask you, but they will meet. When you're gonna draw them backward, they will meet. So they are not parallel lines. Parallel lines will never meet on both the ends. This is their property. Okay. For example, your railway tracks are always parallel. The distance between these two tracks is always equal. This is one line, another line, and the distance between these two lines is always same, and hence they are parallel lines. See, same distance at the starting also, at the ending also, and hence such kind of lines are known as parallel lines. The property of parallel lines simply is they never intersect. Okay, parallel lines never intersect. Also, this is the okay. If I draw a parallel line like this is my one parallel line, and this line is parallel to this one. I'm gonna name it. Let's say this is AB. Let's say this is AB, A and B. This is CD. So if you want to write in mathematics that AB is parallel to CD, how will you write? One way is you can write the spelling AB is parallel to CD in a statement, or you can simply show this way: AB parallel CD. This is not 11, it is bigger than 11. Okay, I'm drawing two vertical lines. This notation itself means that AB is parallel to CD. The symbol that I have drawn here, this symbol itself denotes is parallel to. Okay, is parallel. So when you are not willing to write is parallel to, you can draw this symbol. For example, if I'm saying this line is one line, this line is second line, so you can write one line is parallel to second line. like this. Okay. So now we understand what parallel lines are. We shall understand the property of parallel lines also now. What are the properties of parallel lines are there? Okay. What properties are we having? So there is a pair of parallel lines AB and CD. Now they are being intersected by another line like this. Okay. It's another line. I told you parallel lines never intersect, but there is a third line which are intersecting the parallel lines. Okay, AB and CD are parallel lines, but the black line is some foreign line. That's a external line. Black line is not parallel because it is intersecting, but AB and CD are parallel to each other. Okay, so what about the black line? So when the black line is intersecting my AB and CD parallel lines, it is making some angles. It is making multiple angles actually. What are the angles the black line is making? See, first angle, second angle, third angle, fourth angle. Whenever you see a corner, that's an angle. Fifth angle, sixth angle, seventh angle, and eighth angle. You are seeing when a black line intersected a pair of parallel lines, you are seeing 8 angles now. So there is something interesting about these angles. The first thing is corresponding angles. Corresponding angles. Remember the name because they are very important while writing the reasoning. Corresponding angles. First, you should know what is corresponding angle. So the angles on the on particular side, for example, angle 2 and angle 5. Angle 2 and angle 5. They are corresponding angles. Why? Because 2 and 5 are both on the same sides towards the right, okay, and both are on the top. That's why they are corresponding angles, because 3 and 5 are also on the same sides, but 3 is on the bottom and 5 was on the top, so they are not corresponding. Corresponding angles means similar angles, similar positions, exactly similar positions. So 2 and 5 share exactly similar position. That this is why corresponding angles are equal always. So angle 2 equal angle 5. What about angle 1? So what is the corresponding angle of angle 1? So angle 1 is here. So the angle corresponding to angle 1 is angle 6. Angle 1 and angle 6 share the same positions on the top, and on the left. Both are on the left and both are on the top. So angle 1 equal to angle 6. Corresponding angles are equal. So the first thing is you identify a corresponding angle and then they will be equal. You can use this property while solving questions. Okay. Then angle 4. Angle 4 is corresponding to angle 7 on the left and on the bottom. Both are on the left and both are on the bottom. So angle 4 is corresponding to angle 7. This is why they are equal. What about angle 8 and angle 3? They are also corresponding. Angle 3 is corresponding to angle 8. They are corresponding. Corresponding means they are on the same positions. In what system? First of all, the condition is there should be 2 parallel lines and there is a third line intersecting each other. Then when the third line intersect, it forms certain angles, and then you know the properties. So this particular angle, the angle on this corner is equal to angle on that particular corner. So what I'm saying, angle on this particular corner equals angle on this particular corner. This is how you can imagine this particular. These angles are equal. This was about the corresponding angles. Okay. What about vertically opposite angle? Do you remember about that? Yes. In the foundational thing, in the one of the 4 things that we have seen in the starting of this chapter, one of the thing was vertically opposite angle. If you remember, angle which are opposite to each other. So there is a line. See, AB is a line and black line is a line. So these are intersecting each other, which makes angle 1 and angle 3. Angle 1 and angle 3 are vertically opposite. So angle 1 is also equal to angle 3. See, this is my angle 1 and this is my angle 3. They are vertically opposite to each other. Also, angle 2 is equal to angle 4. By what property? Why vertically opposite angles are equal? Angle 2 is equal to angle 5. Why what property? Why different property? Corresponding angles are equal. So you should know what is corresponding angle property. You should know what is vertically opposite angle property. Only then you can write the reasoning. Okay. I can write here also that angle 6 is equal to angle 8. By the same vertically opposite angles are equal. So angle 6 equals angle 8 because angle 6 is opposite to angle 8. And angle 5 is equal to angle 7. They are also vertically opposite to each other. Okay. So corresponding angle was one thing. Vertically opposite angle we have already seen in the first part. Second property after corresponding angle is alternate angle. Alternate angles are also equal. Alternate angles are equal. So what are alternate angles? See, wherever you see a Z shape, a Z shape, then alternate angles will be there. So I'm drawing the shape so that you can see the Z shape very clearly. Okay, with the red ink I'm drawing the Z shape. It is already there, but you were not able to see it. But now you can see the Z shape. So now you can, since I have highlighted the Z path, then you can see the Z shape in the figure. So in the different diagrams, the question that they will give you, you have to identify the Z shape. Wherever you can identify a Z shape, alternate angles will be equal. Alternate angles means opposite angles. So angle 4 is opposite to angle 5. That means angle 4 is equal to angle 5. By what property? By alternate angles. Alternate angles are equal. Again, there is a Z here also, an opposite Z. I'm going to draw with a different color this time, a pink color for example. See, this one, and this path. Again, this is what? An inverted Z. And again, angle 3 is alternate to angle 6. So angle 3 is also equal to angle 6. 3 is equal to angle 6. This was alternate angles are equal property. Then comes co-interior angles. Okay, co-interior angles. So let's talk about that now. Let's reduce some of the mess and then let's see the co-interior angles also. Okay. Co-interior angles are interior angles. So they see interior angles. These are the interior angles. Let's say this is angle 2, this is angle 5. Hypothetically, this is angle 2, this is angle 5. So they are interior angles. See, this angle and this angle, they're inside. Again, let's say this angle is 3. This angle is 6. So 3 and 6 are also inside. So angle 3 and angle 6 are co-interior angles. Angle 2 and angle 5 are also co-interior angles. So what about them? The sum of co-interior angles is 180 degree. 180 degree. That means angle 3 and angle 6 are co-interior. So sum of angle 3 and angle 6 will be 180. Angle 2 and angle 5 are also co-interior. So sum of angle of co-interior angles is also 180. So angle 2 plus angle 5 is 180. Co-interior angles will always sum to 180. I hope this thing is clear. So we have seen multiple things here. They may sound like a mess of properties, but it's not. It's very easy once you start solving questions. Okay. Again, I'm telling you, math is not about understanding. Math is about practicing. Okay. Opposite things happen. In physics, you have to understand first and then start solving questions. In maths, you have to attempt first. You have to do the mistakes first and then correcting the mistake. This is how. There is nothing about understanding in maths. Math is all about practicing. Okay? We practice, we do the mistakes, and then we see the answer. Then we find out what mistakes are there. We fix the mistakes, and then we never commit the mistakes again. This is the way we practice math. Otherwise, if you are only reading and watching videos, it's not going to do any good. Okay. Now, how will you write the reason in your answer? See, you have to write the full reason. For example, if you are writing that angle 1 equal angle 3, you have to write on the right hand side in the brackets what property are you using. For example, if angle 1 equal angle 3 by vertically opposite angle. So don't just write vertically opposite angles. No, write the full spelling. You have to write the vertically opposite, or not just the name vertically opposite angles. You have to write the statement vertically opposite angles are equal. Okay. Vertically opposite angles are equal. I'm writing in short, but you have to write the full thing. If you're writing the co-interior probability, for example, angle 3 equal angle 3 plus angle 6 equals 180 degree. You have to write the sum of co-interior angles is 180. So wherever you are writing the sum of angles is this particular angle equal this particular angle, on the right hand side of that in the same line, okay, in the brackets you have to write the reasoning also in statement, and no shortcut. Write your answers in a way that they are going to be the study material for your juniors. Okay, your notes or your answer should be such that even a person who is having no knowledge about this particular chapter should be able to understand it. Write your answer as if you are writing it for a toddler. There should be explanation, not just answers. Your answer sheet should be an explanation, not just an answer. Okay. This is one thing here. There's the question that I can show you on that part. AB is parallel to CD. Two lines are there. The question is as AB is parallel to CD. Okay. A point P sits between them. So there is a point P which is between the lines with angle AB measurement as 34 degree and angle to CD measured as 52 degree. Find the angle APC. Okay, this is one thing here. So P is a point sitting between the parallel lines. First of all, I will draw the parallel lines AB and CD. So I am drawing the lines. Even you have to draw a diagram by yourself. The diagram is not given. Understanding the statement, which will only come by solving questions. So two parallel lines I have drawn as the question has told me. AB and CD. I am going to give them the name AB and CD. This is my A, B line, and this is my C, D line. So AB is obviously parallel to CD. I can see that. They in the question they have said, they were saying that there is a point P sitting between them. So this is my P point sitting between them. Then they were saying the angle the P point is making with the AB line is 34. And the angle to CD is 52. Okay, that means I have to draw a line because there has to be a line to make the angle. So there is a line passing through the P point. Like this. So the angle made by P on the AB line is 34. And the angle, this is 34. Angle made by P on the CD line okay, on the CD line, the angle made by P, we have to calculate that angle. Like what angle is it making? This angle. How will you do it? Angle made by P point on CD line, how we will calculate this angle? So first of all, we know this particular value here. Let's say this is angle number 1. So in the answer you will write, once you have drawn the diagram, then you can write given, what is given to me already, that angle 1 from the diagram equals 34 degree. What are they asking? They are asking you the angle. Let's say it is angle number 2. You can give the name angle number 2. So how will you solve the question? First of all, you will give the reasoning that co-interior angles sum of to 180. We'll say sum of co-interior angles is 180. When you have written this line, that means co-interior angles will be added up to 180. That means angle 1 and angle 2 are co-interior, so sum of them will also be 180. Angle 1 is already known, angle 2 is asked, so angle 1 is 34, angle 2 is asked, it is 180, and then the value of angle 2 is coming out to be 146. 146. That means the angle represented by angle 2, this angle here, is 146 degrees, because co-interior angles are always sum up to 180. All right, this was majorly about 70% of the chapter, including the parallel lines concepts and the simple geometrical concept on a straight line and the angles made around the point, which is adding up to 360. Third part of this chapter is about triangles and quadrilaterals. What is a triangle and what is a quadrilateral? So the name itself is very clear. A shape which is only having three angles. Tri stands for three, angle stands for angle. So a shape which has only three angles is triangle. A shape which has quad angle, quad stands for four angles, is a quadrilateral. So angle means corners. So a shape which only has three corners is triangle. A shape which has only four corners is quadrilaterals. Quadrilateral. So a triangle will be typically like this. This shape is having three corners, three angles. Angle A, angle B, and angle C. This is why this is triangle. What about quadrilateral? Any shape of four sides, because number of angles equals number of sides. So a shape which has three sides will definitely have only three angles. Quadrilateral, any shape of four sides or four angles, they are same. Number of sides, number of angles are always equal in shapes, in polygons. So I can draw any shape of four sides. That means it's a quadrilateral. The shape will be regarded as a quadrilateral. It's a quadrilateral. Okay. That means angle A, B, C, and D. It is only having four angles, four sides. This is why it's a quadrilateral. That means a square, rhombus, kite, rectangle, they are all quadrilaterals. They are all kinds of quadrilateral. Quadrilateral is a subclass. Quadrilateral is like a shape. Okay, quadrilateral is like a family of four-sided shapes. And in that family lies our rectangle, square, kite shape, rhombus, parallelogram, trapezium, whatever shape you remember of four sides is a quadrilateral. So every square is a quadrilateral, but every quadrilateral is not a square, because it can be any other quadrilateral also, not a square. It can be rectangle also, it can be rhombus also, it can be parallelogram also. So any shape of four sides is a quadrilateral. Any shape of three sides is a triangle. What about them? The very first thing, since I have already drawn the angles on the corners, the sum of all angles of a triangle always is 180. Angle A plus angle B plus angle C always is 180. Always. For a quadrilateral, the sum of all angles is 360. Always. There's no exception. In all the shape of four angles, the sum of the all angles is 360 with no exception. In triangle, sum of all angles is 180. Okay. There are ways also to prove this part. How do we know the sum of all angles is 180? Okay. So I can prove it also if you want. Sum of all angles is 180. So what is the way of proving it? See, I can prove that. So I'm going to extend this line here. This line I'm going to extend. And here also I'm going to extend. Okay. And here also I'm going to extend. I have extended the corners like this. Then this B angle, right? B angle. B. and this angle here, this will also be B. By what? By alternate angles. See, there is a Z shape. You can observe Z shape here, right? This shape is a Z shape. I told you alternate angles will be there. So angle B equals angle B right here. Again, angle C will be there also, exactly same, by this logic, with a Z shape. This is also what? Alternate angles. When you will prove it, you have to write the reasoning here. Alternate angles again. And then if you see all the three angles here, angle B, angle A, and angle C, they are made on a common straight line, and the sum of all angles made on a straight line is always 180. That means angle A plus angle B plus angle C always equal to 180. This is how we do it. We can prove the quadrilateral property also. Sum of all angles of quadrilateral is 360. How is it happening? By the same logic. Okay. All right, but they will not ask you the proving part. It's not important. Before moving further, you should know that triangles are specifically divided into three types. A triangle which is having all three sides equal will definitely have all three angles equal also. A triangle whose all three sides are equal, A, B, and C. Angles are small a, small b, and C. So it is given already that AB equals BC equals CD. That means it's all angles will also be equal. That's a law. It has to be there. If sides are equal, angles will also be equal for a triangle. Such a kind of triangle is known as equilateral triangle. Equilateral triangle. Equi stands for equal. Lateral stands for sides. So all sides are equal. That's a symbol of triangle. A small triangle is a symbol of triangle. Equilateral triangle. So what's an equilateral triangle? A triangle whose all sides and all angles are equal. That's an equilateral triangle. Okay. Second part. Second kind of triangle is a triangle whose only two sides and two angles are equal. Not all the three sides, not all the three angles. If all three sides and all three angles are equal, that's an equilateral. But now this time, only two sides and two angles. For example, let's say this is A, B, and C. Angles here, A, B, and C. Okay. But in this triangle, not all the three sides are equal. Only these sides are equal. AB equals BC. AB equals BC. So what is the angle opposite to AB? The angle opposite to AB is C. See, the C angle is just opposite to the AB line segment. Then you can write C. Okay, because C is the angle just opposite to AB. What is the angle just opposite to BC? I have written BC here, but it is AC. Okay. So what is the angle just opposite to AC? This is AC, A and C. The angle just opposite to AC is B angle. So angle C equals angle B. So such a triangle whose two sides and two angles are equal, such a triangle is known as isosceles triangle. Isosceles triangle. Isosceles triangle. Isosceles triangle. Okay. Now, the third only case. See, we have seen a triangle where three sides are equal, three angles are equal. We have seen a triangle where only two sides and two angles are equal. Now, there is a only remaining case, which is when no sides and no angle is equal. All three sides are different, all three angles are different. Like this. See, all three sides and all three angles are equal in this case. A, B, and C. Let's say this is angle A, this is angle B, this is angle C. So angle A is not equal to angle B. It's not, AB side is not equal to BC side, is not equal to CD side. This is how we show not equal to. You can write the statement also is not equal to, but I have chosen to denote with a representation. This is a symbol of when you draw an equal to sign and put a this sign. It means not equal to. Okay. Angles also not are equal to. AB is not equal to the A angle is not equal to angle B. B angle is not equal to angle C. If these conditions are there, the triangle is scalene triangle. Scalene. SCALENE. Scalene triangle. Where no sides and no angles are equal to each other. That's a scalene triangle. And the fourth kind of triangle is a right angle triangle. From the name itself, it is very clear. One of the angle is 90 degree. Only condition to be a right angle triangle is one of the angle is 90 degree. That's it. So that's my triangle. And here I can draw it more specifically. So that's my triangle. And now I'm going to name it A, B, and C. And this angle here, angle B is 90 degree. And this is why it's a right angle triangle. A right angle triangle is one which has one of the angle equal to 90 degree. If there is, because our triangle has three angles, so out of three angles, if any of the angle is 90, exactly 90, the triangle is right angle triangle. Every right angle triangle will be drawn this way only. Okay. Let's talk about quadrilaterals now. Okay, so we are having some kinds of quadrilaterals also. This was all about triangles. Triangles are of four kinds. What about quadrilaterals? A shape of four sides. You already know about this. Quadrilaterals. The example of quadrilateral will be square, rhombus, rectangle. Okay. First thing is square. The property of a square is well known. A square is a shape of four sides whose all four sides are equal. That's a square. So if this is my shape, A, B, C, D, and if all the sides are equal, AB is equal to CD is equal to BC is equal to AD. If all four sides are equal, then it's a square. Also, there is one more property of a square, that all the angles are right angle. All the angles are right angle. That means all the angles are of the value 90 degree. Angle A equal angle B equal angle C equal angle D equal 90 degree. All the angles, all the four angles equal to 90 degree. If this is happening, then it's a square. What about a rectangle? A rectangle is a shape where opposite sides are equal. Just opposite, not all the four sides. In a square, all the four were equal, but no. In rectangle, only opposites are equal. For example, I'm going to name it A, B, C, D rectangle. So only AB is equal to the opposite side. Opposite side is CD. So AB equal to CD. Okay. AD equal to BC. AD is equal to BC. So only opposite sides are equal. But just like a square, here also each angle is right angle. Each angle is 90 degree. That means angles are equal. Angle A equal angle B equal angle C equal angle D. All of them equal to 90 degree. That's a rectangle. So how is a rectangle different from a square? That all the sides are equal in a square, but only opposite sides are equal in a square, in a rectangle. So if somebody asks you, is all rectangles a square? Is all rectangle a square? No, all rectangles cannot be a square, because even there is no rectangle which is a square. Not a single rectangle is a square, because in a rectangle, opposite side, not all the sides are equal. But is all the square a rectangle? Yes, all the squares are a rectangle, because in a square even opposite sides are equal. All the angles are also 90 degree. This follows the property of rectangle. But a rectangle does not follow the property of a square. This means all the squares are rectangle also, but not all the rectangles are square. These kinds of questions are often asked. Third is rhombus. Rhombus is as similar as a square, except just one property, that its angles are not 90. That's it. but all four sides are equal. If all four sides are equal, that's a rhombus. If all four sides are equal, that's a rhombus. Like this. So in here, all the four sides are equal, but not all the four sides are making 90-degree angle. This is AB, this is CD. So all four sides are equal. AB equals BC equals CD equals AD. But not all the angles are equal. This is the property of a rectangle. Only opposite angles are equal. Angle D equals angle B, but even not equal to 90 degree. In a square, all angles are equal to 90, but in rhombus, only opposite are equal, but not equal to 90 degree. Something else. They can be equal to 90, but not necessarily equal to 90. In a square, it is a definite thing that angles will be 90. So only opposites are equal. And there is no comment about being 90. They can be 90 also. That means all the squares are rhombus also. All the squares are rhombus, but not all the rhombuses are a square. It's a deep thing. If you think about it, not all the rhombus are square. Parallelogram. Parallelogram is just as same as rectangle. It's just one property. Not all the angles are. See, rhombus is a tilted square. Parallelogram is a tilted rectangle. That's it. That's the only thing. Only differentiation between them. Parallelogram. So in a parallelogram, unlike rhombus, only opposite sides are equal. In rhombus, all were equal. In parallelogram, only opposites are equal, just like rectangle. But unlike rectangle, not all the angles are 90. That's the only differentiation here. If I'm writing ABCD, only opposites are equal. AB equals to CD, and CD or CB, this BC or BCB, any way you can say it. Let's say BC equals to AD. Only opposite sides are equal. And opposite angles are equal. Not all the angles are equal like rectangle. AB equals angle A equals angle C. Opposite angles are equal. Angle B equals angle D. Okay. Now comes two more quadrilaterals. Fifth one is a kite. We already know about a kite shape. Okay. In a kite, two adjacent pairs are equal. Two adjacent pairs are equal. Adjacent means touching each other, close to each other, the neighboring one. So this is the point of contact of these two. That means if I'm saying this is AB and this is BC, so AB equals BC in a kite. If I'm saying it's D, so AD equals CD. Adjacent sides are equal. Adjacent sides are equal in a kite. One pair of opposite angles is equal. One pair, only one pair. This pair. The vertical pair is equal. That means angle B equals angle D. Not angle A equals angle C. No, it's not. Only angle the vertical pair is equal. Angle B equals, okay, not the vertical pair, the horizontal pair is equal. This one. Angle A equals angle C, always. The horizontal pair in a kite will be definitely equal, always. So adjacent sides are equal. See, the two touching sides will be equal. And then the horizontal angles are equal. Angle A equals angle C in a kite. If this is happening, that's a kite. That means a kite is made out of two isosceles triangle. Kite is nothing but two isosceles triangle. If you see this ABC is one isosceles triangle where AB is equal to BC, and ADC is also isosceles triangle, this one, where AD equals CD, only two sides are equal. Okay, and the middle angle are equal, the opposite horizontal angles are equal, angles A equals angle C, not the vertical angles. The last quadrilateral, which is also important, trapezium. What is a trapezium? So in a trapezium, there are two parallel lines of unequal length. That is the only property. Now join the other sides also. The red lines are, the black lines are parallel. So a trapezium is a formation where only one pair of parallel lines exist. Only one pair of parallel lines. So this, let's name it AB and CD. So AB is parallel to CD. That's one property of parallelogram. Okay. And one pair of opposite angles are equal here also. This angle is equal to this angle. Angle C equals angle D. Since I have shown you the trapezium here, let's talk about the area of trapezium, which is sometimes important. Area of trapezium. How will you find the area of trapezium? For that, if you know the height of trapezium, then you can find the area of trapezium also. Let's say the height of trapezium is AE. AE. Right? AE is the height. H. So what is the area of trapezium? The area of trapezium is simply 1 upon 2 sum of parallel sides. Parallel sides are what? AB and CD. So sum of them. AB plus CD times height. Height is A. So 1 upon 2 sum of parallel sides times height. This is the area of trapezium. So let's say this is 2 centimeter. This is 3 centimeter, and the height is 4 centimeter. Let's say. Then the area of trapezium will be 1 upon 2 sum of parallel sides, 2 plus 3, 5 times height, which is 4, and the area will be 10 centimeter square. So we are not talking about area in geometry. In geometry, we'll only talk about sides and angles. That's all for now. Now the fourth part that we will do is polygons in the next chapter, and then symmetry. Polygon, symmetry, and then circles and congruency. With that, we'll be ending up this chapter.